So here's a log equation that's got a subtraction sign between the two logs, so we're going to have to write this as so we're going to use that log, the quotient rule, when we're, or the quotient property. So I'm going to write the two arguments as a fraction. I'm going to set that equal to 1. Now for this equation, we don't see a number, so we're going to assume the log is base 10, which is a safe bet. So now I'm going to get rid of the logarithm by rewriting this as an exponential. So the x plus 4 over x plus 3 has to equal 10 to the first, because 10 to the first has to equal that expression. Okay, now so then what we can do is treat this as 10 over 1, and now we got a proportion. I'm just going to write the cross products. And then distribute through that 10. And then I'm going to combine like terms. I'm going to move. I'm going to choose to move the x over with the 10 and the 30 over with the 4. So that's going to give me. Let's see, what's that going to give me? Negative 26 equals 9x. And then when divide by 9, divide by 9. So x equals whatever 26 over 9 is. Now what the thing I got to check for is for extraneous roots to see when or if this is ever going to, if this is not going to work. Well, let's see. I have to add, so for this expression, this side here, that has to be a positive number when I'm done. So I know that 9 over, let's see, 26 over 9 is just shy of 3, right? So this is just shy of negative 3. So I'm going to call it negative 3. Well, it's not quite negative 3. So negative 2 point something. I could do that with a calculator. I don't know what it is. Let's call it negative 2.9. It's probably not quite that high. It's probably close. So we know we're working with a number smaller than that. So when I drop that in there, that's still going to be a positive number. So we're okay there. And if I drop that negative 9 and negative 2.9 into that, that's also a positive number. Granted, it's a small one, but it's still a positive number. So that tells me that that is indeed the answer for this equation. I could check graphically by graphing this, and it should cross. If a couple of ways to do it. You could put this into y1, put this into y2, and then they should intersect when x equals whatever 26 over 9 is, negative 26 over 9. Okay? Now this is the same kind of problem. It's going to have a little twist to it. So it's a subtraction. It's base 6. So it's the log. It's not the exponent. It's that quotient property. So I'm going to write x squared over x plus 1, and that has to equal 1. Now I'm going to, just like I did with the other one, I'm going to rewrite this so I don't have a logarithm. So 6 to the first power has to equal that. And I'm going to write that as 6 over 1. Now I'm going to find the cross products. And I'm seeing a quadratic equation here. So that means I'm going to have to set it equal to 0. So x squared minus 6x minus 6 equals 0. Does that factor? I don't know. Could use the quadratic formula. We certainly have quadratic solvers that we can use to find the roots, and that's what I'm going to choose to do. So I did choose to use a solver. I'm glad I did, because those are it's not factorable. So now for either one of these values, I got to check for extraneous roots. That's something you always have to do when you're working with logs or exponentials, for that matter. But it really comes in play with logarithms a lot. If I drop that negative 0.887 to that turns positive, so that's not a problem. And it's also positive here. And then same thing with the x equals 6.873, positive number. Those both should work. So those both should be solutions. Okay, there's no extraneous roots. So hope that helped.